All right, in order to understand surface area, you really have to understand area. All right, surface area talks about three-dimensional figures, and area deals with two-dimensional figures. So area is going to be the amount of space inside of a figure. All right, and the basic shape, let's say a square or a rectangle, let's call this a square, has side length of s. All right, I don't need to say base times height or length and width. If this is side, this is also a side. It's the same. So the area of a square is going to be the side times the side, or a side squared. That'll tell me how much area is inside of that figure, how much space it takes up. An example, numerically, with my awesome figure, if this was 4, this would also be 4, and the area would be 16 units squared. The reason area is always squared is because we're multiplying two sides together. It's two-dimensional. It's 2D. So the unit will always be squared. Okay, now let's do a rectangle. We'll call this the length. We'll call this the width. We could call it the base and the height. It doesn't matter. We find the area the same way we would a square. We would just do area equals length times width. So now if I were to add numerical values to this, let's give them units as well. Let's say this was 7 and this was 3 centimeters. To find the area, I could do 7 times 3. That's 21 square centimeters or centimeters squared. All right. Area of a square, area of a rectangle. Let's move on to area of a triangle. A triangle is actually half of any single parallelogram. A parallelogram, pretty much a rectangle. You'll learn more about those in the future if you haven't in the past. But to find the area of a triangle, it's just going to be half of a rectangle. So the area, there's two different ways you might see it, is 1/2 length times width. Or it might be length times width divided by 2. Either one of those will get you the same thing. If you multiply the length and the width times it by half, it'll be the same thing as if you multiply the length times the width and divide by 2. Okay? The height or the length of it has to be a straight up and down. That's going to be the length or the height of this. Okay? These are called the slant height. Slant heights are the angled. All right, so in order to find the area, we need to know what this measure is. It'll often be given in the earlier stages. All right, but the height, if it's not given, we can use the Pythagorean theorem to make a right triangle. This would be a squared, B, I'm sorry, A, B, no, I'm sorry, that would be A, this would be B, this would be our hypotenuse because it's opposite the right angle. So we can go back and use old concepts and topics that we've learned in the past in order to find the area of any triangle. All right, but for the basics, let's just do a triangle. Let's say the height of this is going to be 6. The width of this is going to be 9. So to find the area, we would have to do 6 times 9 and then cut that value in half. So I could do 54 divided by 2, and then I could just get 27, and that would be, since I didn't label it, units squared. Now, if you wanted to, you could also just cut the 6 in half and get 3, and do 3 times 9 to get 27. Lots of different ways mathematically you could get that. All right, the last figure I'm going to be working with to find the area is going to be a circle. Now, bear with me as I draw this circle. Not too bad. All right, the area of a circle is going to be a center of the circle. The center of the circle to any part of the circle around it is called a radius. Now, if you have another radius, but it actually, you know what? It goes all the way through. It goes from one end of the circle to the other, straight through the center. That is going to be the diameter of the circle. All right. You're often going to be given one or the other, but if you know the diameter, you cut that in half, you have the radius. If you know the radius, you can double it to get the diameter. The area of a circle is going to be pi times your radius squared. Now, pi often can be rounded to, pi is about equal to 3.14. It's an ongoing, never-ending, irrational number. That's what pi represents. That's a whole nother lesson in itself. But the pi, you can estimate it to be 3.14, or you can just leave it as pi in your solution. All right, I'll show you what I mean on this example. All right, so we're going to find, here's a circle. Let's make it the most challenging one I can think of right now. I'm going to give you the full diameter to be 10 inches. The full diameter is 10 inches. So if I want to find the area is going to be equal to pi times my radius squared. My diameter is 10, as I mentioned. So the radius, if the diameter is 10, my radius has to be half of that, which is 5. So the area will be pi times 5 squared. Area will be, I do 5 squared, and I get 25 times pi. This 25 pi is the answer in terms of pi. You can, it's not too uncommon to see it that way. Now that doesn't tell us the exact, well, actually that is the exact value, but that doesn't give us an estimate of what is the actual area inside of this. We say it's 25 times pi, 25 pi's. That doesn't help many people. So now what we can do is I can do 25 times 3.14 and see what that value is. Pull up the old calculator here. Let's do 25 times 3.14. That gives me 78.5. So my area for this circle is about, because it's not exactly, 78.5 inches squared. Now I know it's a circle and we said squared, but area, being that it's two-dimensional, is always going to be squared.